And now we are ready to perform our standardization of the thiosulfate solution. And so I have my burette set up right here. That's what this glass tube is called. This is a burette. This is what we use for titrations. So I have that set up here with my stand and my stir plate. And so the first thing that I need to do is just to put some of the solution into my burette. And so actually, let me get a waste beaker out here. I want a fairly large one. I will be right back. And so the first thing that we always want to do whenever we're using a piece of glassware like this is to make sure that we rinse it out, clean it out, so that it's ready for use. And so what I'm going to do is I'm just going to put a little bit of my thiosulfate solution in here. I'm just going to lower down the burette, put my funnel in the top. Here's the solution that we just made in the previous video. This is our thiosulfate solution. And I'm just going to put in a couple of milliliters into the burette. So not a lot at all. And then what I'm going to do is dump this into my waste beaker, but I'm going to do so slowly, and I'm going to do so, as you can see, I'm holding the burette horizontally. And what I'm doing here is I'm letting the thiosulfate solution run through the beaker, and I'm going to swivel or run through the burette into the beaker, and I'm swiveling the burette the whole time that I'm doing this. And so I'm rinsing any dust, any contaminants, any water, anything like that that was in the burette. I'm rinsing out, and at the same time I'm coating the sides with the thiosulfate solution. And I'm going to do that a couple of times. I'll put in even a little bit more this time. So we've got plenty of thiosulfate to play with. And so again, all I'm doing with this step is I'm just rinsing the burette. I'm getting it ready. I'm cleaning it out, and I'm rinsing it. And I'm rinsing it with the solution that I'm eventually going to put in here. Because that way I know that anything left, because you can never dry a burette completely. You're never going to be able to get all the water and everything out of this. But after I've gone through this process, I've ensured that anything that does remain in here when I put my solution in is the actual solution that I'm going to be using. And so that means that the whole thing is clean, so to speak, and that the only, quote, contaminant that might be in here, that might be coating the sides of the burette on the inside, the only contaminant in there is the actual solution that I want to use. And so now my burette is clean and ready to go. Now, one of the things that you'll notice, so the way that we use these burettes, we've got this stopcock here. Perpendicular is closed, so nothing flows through it when the stopcock is in this position. Up and down parallel. This is now open up. And so any liquid in here would now flow through. And so burettes are designed and they're calibrated in such a way that this tip and all of this region has to be completely full. And so that's the other thing that I'm going to do when I get things set up, is I'm going to put some of the solution in here. And then I'm just going to open this up to clear out any air bubbles, clear anything through, open the tip up, it fills the tip, and then it gets things ready to go. When I do that, I'm just going to show you an up close and personal. You can see what the measurements look like on here. And so these burettes are marked off in tenths of a milliliter. And so I don't know if you can really see that. Let's see if I can. There we go. And so each of those little ticks is 1/10 of a milliliter, which means that I am going to be able to record this and record data to the 100th of a milliliter, because we can always, on any measuring device like this, we can always measure one order of magnitude, one digit past what our tick mark is, because I'll just estimate. If it falls in between 2 ticks, if it's falling in between 1.3 and 1.4, then I can record that as 1.35. If it's dead on 1, then I'll be able to mark it something like at 3.50, and so forth. And so the other thing that I'm going to do when I fill this is the other way that burettes are designed. Again, let me bring this over so you can see it. So starting at the top is our 0 mark. And so as liquid goes through the burette, as I titrate my solution, the liquid's going to go down the burette, and that's how we're going to get our readings. And so if we're starting right at 0 and then we end up down at 2, then that would be 2.00 milliliters. And so that's what I'm going to, and so when I record data, what I'm going to always record is, because we don't need to fill this in between each trial, and that'll make a little more sense as we go, but I don't need to refill this back up to the 0 mark in between every titration that I do. And so what I'm going to be recording for each trial, for each titration, is the initial volume, where are we starting on this, and then the final volume. And so then you'll obviously have to take the difference between those two in order to find the volume of each individual titration. And we're going to be doing a lot of titrations today. And so the other thing I'm going to do when I do fill this up is I'm not going to try to have it start directly at 0. If I do that, that actually introduces a bit of measurement bias into the reading, because I guarantee no matter how hard I try, no matter how much I think I'm actually dead on 0, I'm not. There's a little bit of bias that gets in there. And so when I do fill this up, and when I open it up to fill up the tip, I'm gonna start up above, but then I'm gonna let liquid fall so it's somewhere in between 0 and 1 or so, or somewhere in this range. And then I'm going to record what that actual starting volume is, and then we'll begin our titrations from there. And so that's the bulk of data that you're going to see from this lab, is a whole series of initial volume and final volume for each titration that we do. And so then you'll have to take that difference in order to find what the volume is of each titration. And so let's go ahead and fill this up then. You'll see that I'm making sure to note that the stopcock is closed before I do this. I just filled it up a ways past the 0 mark. Now I'm just going to put my waste beaker underneath. Open up the stopcock and bring it down. And so now I'm ready to go. And so when we are standardizing our thiosulfate solution now, we're going to do that against a solution of potassium iodate. And so I need to prepare my standardization solution. And so I'm just following the setup, the ingredients that were in your lab. Instead of a 150 milliliter beaker, however, I am using 125 milliliter Erlenmeyer flasks for this. Erlenmeyer flasks are better for titration because of the smaller opening. It makes things a little bit more exact for us. And so I'm starting with just around 50 milliliters of water in here, and we don't need this, that part doesn't need to be exact at all. The water just adds a little bulk for us for our color, which we'll see in just a second. So there's my 50 milliliters of water. Then I need to add 250 microliters of concentrated sulfuric acid. This actually, honestly, is one of the most dangerous things that we would work with in a Gen Chem lab. Concentrated sulfuric is very nasty, dangerous stuff. And so I'm going to use this graduated pipette. And I don't need much, just the 250 microliters. It's not a lot. And then I also need 250 microliters of what we're calling solution 1, which contains our 3 molar sodium iodide and also some 8 molar sodium hydroxide. Pretty dangerous stuff as well. Very highly concentrated bases are just as dangerous as highly concentrated acids. So again, I only need 250 microliters, which is not a lot. It's only about a quarter of the way up the neck on this pipette. And we'll squirt that in. The next thing that I'm going to need is my potassium iodate solution. Now, as hopefully was discussed in your pre-lab, the potassium iodate is our limiting reagent in this. And so now I do need to be very exact with this measurement, with my potassium iodate. First thing I'm going to do is just drop a stir bar into my flask. And let's get that stirring. That's just mixing up in here. And so now in order to get my potassium iodate solution, right in this bottle here, my 0.0017 molar potassium iodate, I'm going to use a graduated pipette for this. These are very exact, very precise. And I need 5 milliliters. So you'll note that I'm bringing the pipette up to eye level. I'm getting precisely 5 milliliters. Now watch what happens to the color of my solution when I add this in. So our solution turned yellow. That's the iodine. I2 is a nice yellow color. Just turn up my stirring a little bit. Now the next thing I'm going to do is I'm going to actually drop the level of my burette so that it is below the level of the lip of the flask. And that's another thing that we do for very precise, very analytical titrations like this, because this now guarantees that anything that is coming out of the tip is actually definitely dropping into my flask. I don't have to worry about a little gust or a little breeze coming through just as a drop goes through into my burette, or it goes through my burette into my flask, because literally that could throw results off. When we're trying to be as precise as we're trying to be in an experiment like this, if there's a gap that the solution has to drop through just through the air, even just a little gust of a breeze can get a few little micro droplets or a few little droplets to splash out so they don't actually go into the flask. And so just lowering the tip below the level of my flask ensures a little bit more precision with this experiment. And so I'm going to record my initial volume here. I'm starting at a volume of, and here's just another little titrating tip. Sometimes it is handy. Just use this, I use my prep paper here. And this is a part that you lose out on just a little bit because we are live, so it's tough for you to actually see this. But when I'm getting my readings on the burette here, it can be tough to really see the meniscus that well sometimes. I'm just straightening this up a little bit. This is a little cockeyed here. Here we go. It can be sometimes a little tough to see that meniscus, and so if I put this little black squiggly or the squiggly in behind it, it creates a little bit more of a shadow for me to really see my meniscus and get my measurement. And so my initial measurement for this first run of my titration is 1.20 milliliters. And so now I'm going to add in some of the thiosulfate from my burette. I'm going to open the stopcock up, and I'm going to add in some of my thiosulfate until this turns a much more pale yellow color. And so I'm just going to sort of fire a bunch in there until the color is much more of a pale yellow. And I know you can't see this on your screen, but at this point, there's just a little hint of yellow in there, just a little bit of yellow left. So what I'm going to do now is add in a couple drops of my starch indicator. And we can see that the solution turned blue. Iodine, I2, turns blue in the presence of starch. And so that's what we're adding in here now. It doesn't matter when I add the starch in. We just can't add the starch immediately because there's too much iodine in there at that point. It would overpower the starch. And so we titrate some of this through first in order to react some of the iodine until we have just a little bit of it left, and then we can add in our starch to get our blue color. Now I'm going to go much more slowly with my addition of the thiosulfate. I'm going to titrate until the blue completely disappears. And so this is where I want to go very slow because I don't want to overshoot that. I want to add just enough of the thiosulfate to make my blue color go away. No more than that. And so I'm going to go fairly slowly with this now. And see, I'll put a little bit of it in, then I'll stop. There's a little bit of blue left. Actually, I think I overshot a little bit. And so there's really not much, there's no blue color left. This is completely clear at this point. And so that's the first run of my standardization. And our final volume is at 16.20 milliliters. And so what I'm shooting for with this standardization is I ideally want to have 3 titrations, 3 of these runs that are very, very close to each other. And so very often what we actually do with titrations, when we want 3 that are close, and that's pretty standard when we're doing any sort of analysis with titrations, is to try to get 3 that are close to each other. Very often we'll do exactly what I did here and do one of them that I'm not real careful with, that I'm not real exact with. Sometimes we call that the quick and dirty run to begin with, because this now tells me that when I do my next runs, it's the final volume that I'm shooting for, or the amount, is about 15 milliliters. Which means I know that I can do a fairly quick titration through maybe 14 or so, and then go very slow, go even drop-wise, so that I can, really narrow in on that endpoint. And so that's what I'm gonna do with these next runs, is I know that my target is somewhere around 15, which means that I can go pretty quickly up to that point. And so I might actually end up doing 4 titrations. That's very, very common. And so I'm just going to dump this solution out, and I put my hand in there just so that I could recover the stir bar. We have these little teeny tiny stir bars, and I'm just going to rinse that off. So I've rinsed off the stir bar so that I can put it into, I pre-made my next solutions. So I have 3 more of these solutions all ready to go. Lower my burette tip. And so, and this will be the way that our data goes for all of our titrations today. My final volume on my first run, on my first reading, my final volume was 16.20. So that's now my initial reading for this run, 16.20. And so again, I'm just going to fire a bunch in until I turn a pretty pale yellow. A little bit of the yellow still remains. Here goes my 2 drops of starch indicator. Now I can keep going. So I'm adding in quite a bit until I get to about 13 or 14 or so, and then I'm going to really start to slow down. I'll just go a few drops at a time. blue is starting to disappear when I add my drops in now. So I'm just going literally 2 or 3 drops at a time right now. Blue solution is almost gone. I'm going to go to a drop at a time. Oop, I let 2 go on that one. But I think we're okay. There's a little bit of blue left. I think 1 more drop will do it. Oh, just a tiny little bit of blue left. Oh, and I overshot again a little. So this is tough to do sometimes, to really get that narrowed in. But my blue is definitely all the way gone. And my final volume now for the second run is 37.75 milliliters. Sorry, that's not right. 30.75 milliliters. Rinse off my stir bar and my gloves a little bit. One more time. Just adding in a bunch until just a very pale yellow remains. My 2 drops of starch, one of them got cut up on the side, so I'll give that time to, actually I'll mix this up a little bit, there we go. And so now I can keep adding in. Add until my blue color disappears. I'm getting close. Almost there. And that does it. So for our third trial, my final volume is 45.50 milliliters. So I do want to do one more so that I can be sure I've got 3 good measurements, but we'll notice that I definitely don't have enough left in my burette to do another trial because these have all been about 15 or so milliliters. And I only have about 5 milliliters left, so I'm just going to add in some more. Just refilling my burette with my sodium thiosulfate solution. Again, I'll go up past my 0 mark. waste beaker. Hit my whole apparatus. Be lucky that I didn't knock it all down. Now I'm ready to go for my next trial. I still want my waste beaker here. And so now my initial volume is at 1.25 milliliters. Fire a bunch in until I turn pale yellow. Two drops of starch. Getting pretty close, there's not much blue left. Really close now, I'm gonna try to go one drop at a time. I think one more drop will do it. And we're completely clear. So for our fourth trial, our final volume, 15.70 milliliters. And so that finishes our data for the standardization of the thiosulfate solution. In the next video, we will do the titrations for our Green River samples.